Okay, it's recording. So here is our FRQ. It's 2019 question 2. And we're just going to talk about parts A, B, and C. You can read through the other parts and I'm happy to answer questions on it. But for part A1, it says, suppose the mass of block A has much greater than the mass of block B. So this guy's really, really, really big. Estimate the magnitude of the acceleration of the blocks after release. So you just basically need to give some sort of proper guess for an estimation here. So correct answers could be 0, small, negligible, much less than G, or that's symbolically much less than G. And then you needed to give a correct reasoning. Because it says briefly explain your reasoning without deriving or using an equation. So you got a correct answer. You got 1 point for a correct answer, saying it was one of these things, and 1 point for correct reasoning. And there's a couple ways you could have gone about that. I'm going to concentrate on the earning 2 points section. So if you said very small, because block A has large inertia, it won't speed up much. So it would have lots and lots of inertia. So that would mean it, resists acceleration quite a bit, or close to 0 because block B is so light that it can hardly budge block A. That would earn 2 points as well. It wouldn't be able to, it's talking about, the relationship between the two, talking about inertia, talking about something like that. You could also just make it into a CER. You could say the claim, the acceleration of the block is 0 or smaller, negligible. Evidence, the mass of block A is much greater than the mass of block B. And then you could use one of these examples for your reasoning to get the point too. That would be perfectly fine formatting for AI. For A2, says now suppose the mass of block B is much less than the mass of block A is much less than the mass of block B. So they've switched. So estimate the magnitude of the acceleration of the blocks after release. And I kind of talked about this too. This time they gave you 1 point for correct answer and correct justification. It's kind of important to note that when they read, they don't know exactly how they're going to lay out the points. They know the total points for it, but then they figure out exactly how the points are going to work out. So the readers for this question decided this is how the points would break down. If you said correct answer nearly G or almost free fall or 10 or some variation of that, you got points. So if you said nearly equal to G because block B is almost in free fall, 10 because block A has negligible mass and the tension in the string is nearly 0. Something about how this would be really, really large, and this would, cause very little resistance. So it's almost in free fall. Would be what they're looking for in part A2. Again, CER, the acceleration of the block is close to G. Evidence, the mass of block A is much less. There's negligible friction. The pulley has negligible mass. These are all good evidence to lead you there, and then talk about how it's nearly equal to G because block B is almost in free fall. You could do that format too. That would give you 1 point. Do I have any questions on part A? Okay, then I'm going to do part B. Now suppose neither block's mass is much greater than the others, but they are not necessarily equal. The dots below represent block A and block B, as indicated with the labels. On each dot, draw and label the forces, not components, exerted on the block after release. Represent each force by a distinct arrow starting on and pointing away from the dot. So they give you a lot of information on what they're looking for, but make sure you read it very, very carefully. So you got 1 point for a correct normal force. Here, it might be a little hard to see, but this is Fn. You could call it N, Fn, normal force, table force, or anything talking about it being normal. That was 1 point. You got 1 point for correct gravitational forces. So 1 here and 1 here. with all these different labels. You could have called it MG, MA, but not just big G or little g, because those are different things. And for not putting a bunch of extra forces. If you would put a friction force on one of these, you would not have gotten this point. And then you got one more for tensions. If you set a tension here and a tension here, then you got that point as well. Again, label them many different types of ways to label tension. But you couldn't have said just MG or MB or force from block B, or anything that it's created by block B. Okay, and that was B. Any questions on B? Okay, then finally, this is C, derive an equation for the acceleration of the blocks after release of MA, or after release in terms of MA, MB, and physical constants as appropriate. That usually means like little g or big G, or some constant, pi, something like that. That would be perfectly fine to incorporate. But that's all it wants: MA, MB, and pi. And if you need to draw anything other than what you have shown, it says in your solution, use the space below. Do not add anything to the figure. So it doesn't want you to add to it here. I want you to leave these alone, but you can draw it in that space. So a couple things you could do. I recommend this whole system approach. So that's what I'm going to emphasize first. Writing the whole system equation, like F net equals M total A, or M system A, that doesn't contain internal forces. So it wants you to get rid of those FTs, like I did when I was talking about it. And then substituting the net force and the system masses. So the net force, the only force acting on it that is causing an acceleration is this FG. So it wants you to put that FG in terms of the mass of B times G, FG equals M times G, and then MA plus MB, both of these contribute to the mass of the system, so they need to be incorporated. And if you just wrote a whole system equation like you wrote, MGB equals MA plus MBA, you would have gotten this point too. And then finally, solving for A is the final point where you divided both sides by MA plus MB, and you got MB times G. You could also just have left it together, divided by MA plus MB would give you the final acceleration too. You could do it a slightly different way. You solve for the equations of both. You combine them together. It indicates the tension, it's the same tensions, and they share the same acceleration, something along those lines, and then some work that got you there. So if you did that too in a slightly different way, that's okay too, but I like this way. So that's why I indicate it. Okay, so that's A, B, and C. You could do D and E. E deals with torque, so we haven't talked about it yet. You could do D too, but we're short on time. So I'm going to stop recording, and then